All right, Unit 6 is some review on functions. So it's the state has Unit 6 and they really kind of hone in on features of functions. Remember, we've talked about 3 specific types of functions: linear, quadratic, and exponential. I have an example of what each of those looks like. So if you were to be given a function and asked what type of function it is, you're going to have to simplify first so you know. So here we multiplied that x all the way through because I have the parentheses. I need to distribute. And I end up with an x squared term. Anything with an x squared, that tells me it's going to be quadratic. It's going to have a minimum value. It's going to open up. Here, when I distribute that 3 through, I end up with 3 minus 6, and then bring down the minus 4. I add my like terms. 3 minus 4 is negative 1. This guy is now written in slope-intercept form. Negative 1 minus negative 6x. This negative 6 in front of the x, that's my slope. That's my m term. So this tells me that I'm going to be decreasing in my line. I'd also have a y-intercept of negative 1. And then this last one here is exponential because it's raised to the x power. If the variable is the exponent, you know it's exponential. And this is going to be decay because I have this 1/2 here. Remember, anything, if your rate is between 0 and 1, it's a fraction between 0 and 1, you're going to have decay. If your rate is greater than 1, you're going to have a growth problem. I'm not going to talk specifically about these 3. We've talked about identifying arithmetic versus geometric sequences. Remember that your arithmetic is going to be linear. That's when you look for that common difference. And then your geometric sequences are going to be exponential, and that is when we look for that common ratio. Okay, so just a little refresher on what we've talked about before. So comparing with inequalities, we want to look at the graphs of the functions f of x equals x squared minus 1. So that's the parabola because it's x squared. And then I have g of x equals x minus 1. Well, this is a linear, so that's just that straight line. So I want to know what transformation makes g of x greater than or equal to f of x for this domain here, this specification of x. So from negative 2 is less than or equal to x is less than or equal to 3. So if I look at the graph from x is negative 2 over to 3, I want to make g of x greater than or equal to f of x. Okay? So here's my linear function g of x. I want that to be greater than or equal to. So if we look, if I want my functions to be greater than or equal to at these points. So see here where x is at negative 2 on my line right now. I want to make it greater than or equal to, so I want it to intersect my quadratic function right here. So same thing here. Right now my line x equals 3 is right here, but I want it to intersect when x equals 3 on my quadratic function. So if I count 1, 2, 3, 4, 5, 6 units up is how much it's going to take for me to get to negative 2 on the quadratic. And then here 1, 2, 3, 4, 5, 6. It's going to take me 6 units to move up to that point on the quadratic. So we shift up 6, which means I just add 6 to the end. And if I want to make the transformation make g of x less than f of x for all values of x, I don't want them to be crossing at all. Okay, so right now they have some point of intersection where they're equal, so I would just need to move it down 1 unit so that they're not touching, and then it's always going to be less than that other function. So some applications of functions. Alice finds that her flower bulbs multiply each year. Okay, so I'm going to kind of highlight that word. She started with just 24 tulips. After 1 year, she had 72 plants. 2 years later, she had 120 plants. We want to find a linear function to model the growth of Alice's bulb. So it tells me I'm using linear function, which means I know I'm using y equals mx plus b. I'm starting with 24. That's where we begin. That's my y-intercept. And then I can use the data that they gave me in the problem to find my slope. Okay, so it tells me that we started with 24, and then after 1 year we went to 72, and then after 2 years we went to 120. So when we subtract these, 72 minus 24, we get 48. 120 minus 72, we get 48. So my slope is 48. Plug in my slope, plug in my y-intercept, there's my function. Now suppose Alice discovers she counted wrong the second year and she actually has 216. So notice how this changed from 72 to 216. She realizes the growth is not linear this time because the rate was not the same. So now we're going to use an exponential model. Remember, this is your y equals a times b to the x. To find the exponential function, we need to find the growth rate. Okay, so 216 divided by 24, that's what gives us 9. So that's my rate, that's my b value. And then a, that's my initial value, that's still 24. So 24 times 9 to the x would be the exponential model here. One other little aside, when we're dealing with functions, if you're unsure about how to graph it, remember to use that table. Just start plotting points, -2, -1, 0, 1, 2, and that will help you kind of narrow things down. Also look for your y-axis, your y-intercept, where x equals 0. That can also be something that can help you graph as well.